Additive manufacturing is a really exciting technology with a lot of new applications for designers and engineers. So just the fact that additive manufacturing allows you to make every object as a personalized object, individualized object, we can basically really customize stuff for end users. Then another interesting question is how much can the end users actually customize those products? So which parameters should be open for customization and which should be fixed? So one example how such a design tool could look in the future is that designers just specify high-level functions and then the software basically fills in the structural or other functional aspects of the design.
Additive manufacturing is well known within the automotive industry since decades. So we call it rapid prototyping since more than 25 years, and it has been used in the automotive industry since then. This was always driven by what I would call process innovation, so driven by the flexibility for low volumes and then flexibility in terms of location because of the toolless character of the technologies. So that was process innovation. Now we come to a level where we talk about product innovation. Product innovation meaning we create superior product designs, so designs that couldn't be created using conventional manufacturing technologies. We see the first examples within other industries and we see first examples also in automotive. But there's an even further vision of the technology. You shouldn't see additive manufacturing as an end in itself. You should see additive manufacturing as part of a data-driven world for both directions, for product innovation and process innovation. Talking about product innovation, it's really about leveraging data, algorithms, and even artificial intelligence to create superior designs and bring the full potential of the technology in our components, into our cars. And in terms of process innovation, you could think about a future where today we create components based on assumption and existing engineering data. And once the component has been approved, you will not change it because you can't change the tool and you have a business case for a specific number of parts that have to be produced. Using additive manufacturing, you don't have to produce any tools. So you can also change the design and it gives you a level, what I would call agile hardware development. So you can create a component, develop a component, and based on the information of the first component that is used in a car, you can redevelop and improve the component for the day after, so the component that you're printing the next day. Basically, additive manufacturing is part of this digital advanced value chain because it's the only technology that allows you to physically realize designs that you have developed based on data and improved based on real collected information.
We've invested heavily in cloud over the last decade. And so as the data can flow through the cloud, then as you're compiling the data, then you can start to apply machine learning, artificial intelligence, generative algorithms that are using more than just math and physics, but using data that's actually collected on the part in use.
One great part about additive manufacturing is also that it allows to produce objects just within hours or even minutes. So we can also imagine having a customer be directly involved in the design process. So for instance, I'm the product engineer or the product designer, and now I can produce a prototype just within minutes. For instance, have the customer on site, get the feedback, and just keep iterating. And the exciting part about the 3D printing speed is today it's still taking hours to print something, but there's actually data that shows that 3D printing speed doubles every 2 years. So we can even ask ourselves in the future, can we print something within minutes, maybe even seconds, or can we even print in real time? So as I make my changes on the editor, can I see the physical changes basically immediately? So yeah, on the design tool side, there are a lot of interesting questions, like how much should the user be involved in choosing the design parameters? And for this, I really like to make the comparison to 2D photo editing, right? So we all know there are very simple tools that allow users to just change a few parameters, like these photo editing tools where you just apply a filter and everything looks great, but you feel you have customized it. Right? On the other end of the spectrum, there are people who use, for instance, Photoshop, which is a very complex tool, needs more learning, but also gives you more opportunities to customize. So there's no single answer to how much should the user be involved in the process. It's really all about how much do the user want to be involved. So these design opportunities really become possible because of this additive manufacturing capabilities. So before that, with mass manufacturing, you needed to produce a mold first. And a mold really just pays off when you create thousands and thousands of the same kind of object, exactly the same. With additive, however, we can create every object on an individual basis without adding anything to the cost.
That's what I've been able to think of as adaptive. Manufacturing becomes an adaptive process, or manufacturing can be adaptive to market demand, to design needs, to customer needs, to the ability to incorporate new materials, et cetera, et cetera. The systems and workflows we talk about throughout the course, as well as translate upon to more advanced digitized production systems, the goal is in a way to be adaptive, whereas while so effective for our modern way of life, manufacturing now is highly unadaptive.
Customers and the larger industry are seeking solutions to problems that didn't exist in the same way in the past, right? So the old model of producing a lot of the exact same thing and having a few products, a few SKUs, if you will, that are kind of the cash cow for the business and that last for a decade. We're seeing that far less and less, right? And as you think about the Internet of Things, that's one of the drivers, right? As internet technology gets incorporated into mechanical products, those mechanical products start to need replacement at the rate of change of the internet, right? So take watches, for example, right? I'm not wearing a watch right now, but a traditional analog watch might last decades, right? People have inherited that from their fathers or grandfathers before them. And even digital watches, even the simple non-internet enabled digital watch, right? I've had one for 20 years. But I'm certainly not going to have a smartwatch for 20 years. I may not even have it for 2 years before I'm going to replace it, right? So that's one big trend that's driving change in manufacturing, right? And that has tremendous ripple effects throughout supply chains, right? Personalization is another one that I touched on. Localization is another one, regionalization, right? So we're seeing more and more SKU proliferation, shorter product life cycles, and more variety and customization. So all of that puts pressure on a traditional supply chain, right, that's used to making a few things many times. And a digital thread is one way to address this, right? By automating the front end of the manufacturing process, so focusing now on the part of the manufacturing process that starts with the design and allows you to make first parts quickly and inexpensively. While the old model was making those first parts may take you 4 or 5 months and $50,000 to $100,000 of capital investment. And that's fine in a model where that thing's going to be in the market for 5 or 10 years and you're going to make millions and millions and millions of them, right? You're going to get tremendous payback and ROI on that upfront investment. But in a world that's changing as fast as ours is, that's just simply not true anymore, or it's not true as often as it used to be.
If you think about the technology and its strengths, they all lead to a transfer of control, lead to a transfer of power within the value stream, and frankly, they invite people to participate who have not traditionally been part of it. So if you start using additive to manufacture at the point of use, you're effectively asking your customer to manufacture for themselves. And the customer can midstream modify that product, your product. So all of a sudden, your customer is a manufacturer and product designer. The customer can actually, in parallel to your own development, product development, be developing the same product and following and intervening in that process. So you see this incredible empowerment of customers and the power and the assets essentially moving down the supply chain towards the point of use.
For many years, since we started to industrialize production, access to production capacity by the small or medium enterprise in terms of the knowledge required, the network connections, as well as the capital, has made things prohibitive. And sort of society, developed society went through this period of relying, perhaps excessively on mass manufactured goods. And the equilibrium between, what you really want, the user wants in their product, performance, aesthetics, et cetera, and what's possible with these new digital technologies is changing that part of things too. Just this morning I was reading an article about the renaissance of the instant film camera. So like Fujifilm and Polaroid are selling instant film cameras again, and nowhere near digital cameras, but these are becoming viable businesses again because people like the experience of instantly producing a physical artifact. We're so used to taking digital photos, and in a way I see an analogy to 3D printing for arts and crafts and design, right? Artifacts for the home, or small quantities of eyeglasses, or in a way semi-custom clothing or shoes will engage consumers, will engage designers in a different way. I'm excited about how the consumer's interface with the product might change, and in some ways, right, customization of products to yourself is costly, right? Because you have to pay more to have something customized. Also, at least for me personally, sometimes it's challenging to get that customization done, right? To go somewhere, to spend a lot of time, to maybe not be guaranteed a fit, for instance. But if I know that the customization is more likely tailored to my preferences, and there's maybe a digital interface that will help me get there, I'll be intrigued to try it out. In part because I like technology and like trying these new interfaces, but in part also because it gives me confidence that it's more likely to match with my preferences. We can rethink so many tangible ways that we design products, we do business, we build a tool, and those specific rethinks are the things that excite me the most because it shows the true potential that challenges our conventional way of thinking, way of manufacturing.